Welcome back. We are going to be talking about one of our first types of reactions today, but before we start talking about reactions, we want to just get the groundwork down on what we need to do when we're writing chemical reactions. Understand that we've been doing all that practice with formula writing, so we can do this. And we have 5 different reaction types that we have to learn: synthesis, decomposition, combustion, single replacement, and double replacement. And they're all going to be easy, don't worry. We just have to kind of learn the different skeletal models of what each is. Now, the most important thing though, look how big and bold and obviously important this sentence is. When you're writing correct equations, you always write the formula first and then balance. Don't try and balance while you're writing. It's impossibly difficult. Just don't do it. Write the whole formula first and then balance the equation. Ready to dive in? We're going to start with our first one, which is called synthesis. Now, synthesis can also be called composition reactions. This depends on what they call them. But all synthesis is the combining of 2 or more simpler substances, they're often individual elements, to form one single, more complex substance. Now, ionic substances are always going to be considered solids at room temperature. Now, most of the time, unless you're asked to do it yourself, if it's a really tricky situation, I'll tell you what the state of matter of something is. But in other words, if you're looking on the table and you see that something is like a metal and you're trying to write out the state of matter for it, the metals are oftentimes all solids at room temperature. Ionic things are all solids at room temperature. The only things that are not going to be solids at room temperature are things like water, of course, the gases, so your Hofbrinkel gases except bromine and iodine are all gases at room temperature. So things like that. Consult your periodic table. It should help you understand what state of matter you're going to be in. But if we were to talk about a really basic formula for synthesis, right? Just a general formula. We're going to use the skeletal structure of A plus B. And these are just general elements. They don't actually have any meaning. B doesn't mean boron. It just means anything. We're going to combine those two things. We're going to synthesize, and we're going to get some product AB. And this lines up with our definition. 2 individual things combined together to make one thing that's much more complex, right? So let me show you the easiest of easy. Let's write the balance equation for the synthesis of sodium chloride. So, what I like to encourage you to do in synthesis is actually work backwards. What is sodium chloride? Take a second, we'll think about it. Sodium chloride is NaCl. And it's a solid at room temperature because it's an ionic solid, right? So now that we have NaCl, that is the AB part, right? So let's work backwards. Let's slap an arrow behind it. Give yourself a little space in case you have to balance. And let's try and figure out the 2 components that make up NaCl. Well, this isn't so hard, right? It should be sodium, and it should be chlorine, okay? So after you write those 2 things out, you have to always ask yourself, are any of these things diatomics? In other words, are any of these one of my Hofbrinkel gases? Sodium, is that a Hofbrinkel gas? No. Chlorine, is that a Hofbrinkel gas? Yes, it is a Hofbrinkel gas. So I need to write Cl2 instead. And since I said that to myself, write Hofbrinkel gas, I know that chlorine is going to be a gas at room temperature, and sodium is a solid at room temperature, right? So am I done? Not quite yet. I have to balance this. And sometimes it's easy to balance these things, sometimes it's not. So remember that we're going to balance just based on the number of things we have on the left compared to the number of things we have on the right. So in this case, the sodiums are good, but I have 2 chlorines on the left. I only have 1 chlorine on the right. I have to fix that, but that ruins my sodiums. Never fear, I can fix that as well, right? Easy peasy. Let's try another one. Let's look at something like magnesium bromide. Magnesium bromide. Okay, so again, what is magnesium bromide? Well, it's magnesium and it's bromine, but don't forget to balance your charges, right? Magnesium has a charge of +2, bromine has a charge of -1, and that's going to be solid at room temperature. Doing the same thing I did before. Nothing changes. It's just the same thing over and over and over again. What makes up magnesium bromide? Magnesium does. And bromine does. Is magnesium one of my Hofbrinkel gases? No. Is bromine? Yes. Now be careful. This is the tricky part. Bromine is the only Hofbrinkel gas besides iodine that is not a gas. It's actually a liquid at room temperature. So make a little note for yourself. Box that, star it, write a little note for yourself if you got to. Bromine is not a gas at room temperature. It is a liquid at room temperature, right? Magnesium is solid. It's a metal. Makes it easy. That's already balanced. Did it, but it didn't have to do anything. Not so bad. Let's try another one. We could do this till the cows come home. Iron 3 oxide. What I'd like you to do here is I'd like you to take a second, pause the video in earnest, pause the video, try and figure out the synthesis equation for this. Maybe first take a second to make sure you're comfortable writing out the formula for iron 3 oxide. Just pause for a moment and try it out. I'll come back. Hopefully this is what you got before you even started balancing anything. You know that you have iron 3 oxide, which is Fe2O3. And what makes up iron 3 oxide? Well, iron and oxygen. Oxygen is one of my Hofbrinkel gases, so it's a gas at room temperature. And iron is iron, it's a solid at room temperature. So now we just have to balance this. If you'd like to take a second and try and balance it, maybe pause me real quick. But in case that you didn't, this should be 4, 3, 2. Okay? Not so bad. I'm going to give you one more to try on your own, and then we're done for today. So, let's look at carbon monoxide. I want you to start from the top and just balance out carbon monoxide, or write the synthesis equation for carbon monoxide. If you don't remember, carbon monoxide is CO. All right, give it a shot. Hopefully this is what you got. Not so bad, right? That's synthesis. We'll see you in the next one.